Body.
Rotational.
So planar motion means the body which is taking translation motion plus rotational motion. So that is what we used to call as planar motion. So in this, the most important motion which we need to understand is translation motion. So if you take, rotational motion, for a translation motion, remember, whenever the body is traveling translation motion, each particle having the same velocity and each particle having the same acceleration. So acceleration of any particle in the translation motion is remains same, and velocity of any particle in the translation motion is remains same. But what about rotational motion? So because rotational motion is the most important one for us. So let us talk about that, because this entire chapter is talking about the rotational motion. So rotational motion. So let us consider now. So we all people knows any kind of a scale or whatever it is, like let me take for example, let me take the picture. Long scale, long scale fixed with the pivot. Just I'm trying for image so that you can find it. Okay. Okay. Otherwise, I'll draw. No issues. Okay. So now let us observe. There is no figure. Okay. So all of you observe. There is, imagine, like I will take one rectangular scale. Just make it. So this is my pivot point, fixed point. Okay. And there is a rectangular scale which has been observed, like attached to this body. Okay. So this is what it is. Now what will happen, guys? With the help of these, pivot point, my body will it will start rotating. Understand, Rudresh, what I'm trying to say? So this is a fixed point. This is the pivot point. Okay. So with the help of this whole body will start revolving. Okay. Now, so what is the axis of rotation? This is what is the axis of rotation. We all understand, everyone. So the body will start revolving and it will come like this. So what is this point is called as, everybody? A fixed point we used to call as what? Pivot point. Okay. Now I will choose certain particles. This is, let me take particle A, and let me take particle B, let me take particle C, let me take particle D, and let me take particle X. Now when the body, the scale is start rotating, all of you tell me, do you think that the distance traveled by every particle is remains same? Anybody can tell me? Particle A, particle B, and particle C, is the distance remains same? All of you?
No, sir.
Yes, please respond. So imagine now the scale comes here. This is what is the position of the scale. All of you observe. So now, do you think that the distance traveled by every particle is remains same, Mr. Pradosh? Yes, please respond, all of you. Yes.
Sir.
So if you notice it here, all particle, if I take particle A or particle B or particle C, whatever I can take, every particle in a same motion. What is that motion, anybody? About a fixed point. About a fixed point. Every particle is traveling in the same path. There is a particular path. What is that called as? All of you. All internal particles, they are traveling in the same path. What is that path, guys? There is a motion. Yes, please. Which motion? Circular motion, not translation motion. Circular motion. So A part will take and it will come like this. Correct? B part will goes like this and it will come like this. Of course, the distance traveled by them is not same. Of course, we are going to study that. So every particle will take the circular path. Am I right or wrong? All of you, please respond.
Sir.
All internal particles undergo circular motion about a what point, everybody? About a fixed point. About a fixed point of rotation. So that about a fixed point of rotation is only we used to call as what point? Everybody? We used to call as pivot point. Understand? Now, if you notice it here, is this pivot is compulsory that for making the object to rotate? Anybody can tell me? How many of you know the spin? Do you all people know spin? Spinner. Yes, Pradosh?
Yes, sir.
So spinner, if you notice it, there is no kind of pivot point. But if you notice, for example, take your pen, all of you. Take your pen. How many of you are sitting in the floor or bench, whatever it is? All of you observe. So you are having a pen. Put the cap immediately. Everybody put the cap, and you start rotating. Or else remove the cap. Let me imagine this is what is some cylinder or something. Now, with your finger hit at this position, you observe that it will start rotating or not. All of you have to say me. Is it rotating or not? Spin. Just check it. There is a point. The whole mass is located at a particular point. That point we used to call something. We already studied that. Anybody? Whole mass of the body is rotating somewhere. That is what? Center of mass. What is to call? Center of mass. Now, COM. We used to call it as COM. All of you try to rotate the pen. I cannot show you correct. You can make it. Just try, everybody. So now all of you observe. Every particle in the pen is taking the circular path. Am I right or wrong? All of you? Yes, please. Respond, Ra. So now here there is no fixed point. There is no, like what we can say, there is no fixed point. Understanding all of you? So, but still whole bodies, each particle is taking the rotation. So means in the sense of, it is a what? Everybody? What motion it is? Rotational motion. So that is what, from this I will say, is it necessary that for making the body in a rotational motion, do you think it is necessary to make the body like what we can say that pivot point is necessary? Anybody? Yes, please. Is it necessary to rotate the pen or any kind of object? You hit your things. I'll show you the video also. Let it be. So from that, what you should understand, not compulsory that pivot point is present. For rotational motion, pivot point is there. Every point will rotate about that fixed point. If no pivot point, then what will happen? Just observe here what will happen in this. You can see that. So pen is rotating about a fixed point. That point, a whole mass is located at this point. What is that point we used to say? Everybody? Center of mass. Correct or not? So now he see that he is rotating here. He's making. Let me see that. So we are not this how to rotate the pen. We are not learning. So you can see that about a particular point, whole mass, there is no fixed point. That there is no pivot point. But each particle of the pen is keep on rotating. Am I right or wrong? Yes, please. So he is not rotating.
Yes.
So you can take it is rotating like a spin. Let me take the spin. You all people knows that. So there is no fixed point. So all of you notice how the spin will rotate based upon a particular point. Where it is that spin. Yes. So you can notice it. There is no spin at all. YouTube. Right? This is very, very bad. So, okay. So if you are talking, notice the spin also. I think many people you are already handling the spin. You can notice it. So spin also, if you see, just if you rotate like bench, you can see. If you put it at one side, it will start rotating at a particular point. Am I right or wrong? So the whole mass is located in a particular point. About that particular point, this will start rotating into a different directions. Am I right or wrong? It will start making rotation. So this is what we used to call as, see that body will start rotating about that particular point. Here there is no fixed point. So that is what we can say. Rotational motion is not that compulsory. Which is not compulsory, everybody? Yes, please. Compulsory that pivot is present. Whenever you give a sudden force we used to call some physical quantity. Anybody can tell me? Sudden force applied in a short period of time. Force applied in a short period of time, we used to call something. Impulse. So if you give a sudden force to any kind of body without center of mass is not existed. Still, the body undergoes rotational about COM. Understanding? So there is no fixed point is existed. No pivot point is existed. So whole body will rotate about a a particular whole mass where the body's center of mass is located. So this is what we used to call as example. If you take a spin, so spin is the example for rotational motion where what will happen? The body does not have fixed point. Pivot point is not existed. So if you want, you can try place your scale or pen or something on your bench and whole mass of the body is existed. So give a sudden force. You can notice that your body will, that scale or pen will start rotating, keep on. Am I right, everybody? So that is what we used to call as rotational motion. So it's a circular motion, maybe with pivot or without pivot. That is what. Now, so this is what about it. I hope everybody understand. Am I clear? Yes, please.
Yes, sir.
Now let me take, for example, so I am taking a pivot point. I will fix it. So what we are going to study in this chapter exactly. So many new terms will come. So imagine that this is what a rectangular object which has been fixed to a pivot point. So I will start rotating. I will take it into particular angle. So now imagine this whole body is here. Okay, Pradosh, whole body is here. So I will taking many things, like we can notice this is what arc, actually the displacement if you want to find it. So this is the particle 1 and this is the particle 2 and this is the particle 3 which has been reached here. So it is making, so every particle undergoes a circular motion. Am I right or wrong? All of you? Just
Yes,
please respond. So every particle will undergo a circular motion. So which we already studied in Newton's laws of motion, motion in a straight line, motion in a curved, like a motion in a plane and all. So just very simple, similar to that only. So you can notice it here. So when it is in a straight line, we used to call some motion. What is that called? The body is traveling in a straight line. We used to call something. What is that called as? Linear motion. Now, body is rotating. So that we used to call as what motion it is? Everybody. Angular motion. Understanding all of you? So now, this is already we studied in circular motion. In circular motion, you can check it. Already we have studied the differences between circular motion and linear motion. So linear motion, what is the distance formula? Distance symbol, everybody? Distance symbol is what? Linear motion. Yes. Angular motion, what is the distance symbol? Angular motion, what is the distance symbol? Everybody? Theta. Linear motion, what is the velocity? Linear motion, what is the velocity? Everybody? V. Angular motion, what is the velocity? Anybody can tell me? Which we already studied. W.
Omega.
Omega.
Understanding? Next. Linear motion is two types. Of course, you can see motion is acting whenever, if the velocity, so when the body is in linear, like you can notice here. So two things. The one is the body is always acting, like if you take the circular motion. So circular motion at any point velocity is acting what direction? Direction of velocity. Anybody can tell me? Perpendicular, tangent. Correct or not, guys? And another acceleration which is acting downward towards the center. What is that one we used to call as? Yes, please.
Centripetal.
Centripetal. So one is tangential acceleration, AT, and another one is centripetal acceleration, AC. Now here, angular acceleration. See here, tangential acceleration or circular acceleration. Sorry, centripetal acceleration. Centripetal, please write it. Centripetal acceleration. Now here angular. So that here what will happen? Angular acceleration. So angular acceleration symbol is alpha. Angular acceleration symbol is alpha. Next. Here the applied force is F. So in circular motion, rotational motion, what is the applied force? Applied force is equals to torque. Please remember, this is the symbol of torque. Torque. What is to call this one? Everybody? Torque. Okay. So please write torque. Now, according to Newton's second law, what is the force formula? F is equals to everybody? Mass into acceleration. Understanding? So now here torque formula is, all of you remember, torque means I into alpha. Alpha means what? Angular acceleration. I means what we'll study. So here mass means M. In this rotational motion, mass we won't take it. We won't take it I. I means moment of inertia. Now you might be understanding. Inertia is directly proportional to something. Anybody can tell me? Newton's first law of motion. Newton's first law.
Mass.
Yes. Mass is directly proportional to what? Inertia. So inertia means opposing to change its position. Am I right, everybody? Clear? All of you? Yes, that is what. Next, momentum. So what is the momentum symbol here, everybody? Momentum, 9th class you studied, even 10th, now also you study. Momentum is equals to what? Mass into velocity. So this is momentum, also we can call it as what? 9th class you study, linear. Momentum, or we can say linear. Now here rotational, angular momentum. Angular momentum is symbol is L. So this is what? Angular momentum. So please all of you remember. So this is the difference between that. Many symbols will get it in this chapter, like distance, angular distance, velocity, angular velocity, acceleration, angular acceleration. This acceleration is two types. One is always tangential acceleration, and another one is what? Tangential acceleration and centripetal acceleration. Next, force. Here force, here what will say? Rotational motion, torque. F is equals to ma, here I into alpha. Moment of inertia into alpha means what, guys? Angular acceleration. Here momentum or linear momentum, and here what will happen? Angular momentum. Okay, so this is what about it. Then from here we will study what is this about this all. Theta, S, V, omega, A, tangential acceleration, centripetal acceleration, angular acceleration, net acceleration. These all the things will continue in the evening class. So till here, I hope you all understand. So only three things we studied. One is translational motion. Next one is what? Rotational motion, and one planar motion. What is rotational motion? Rotational motion, all the particles they are taking in a what part? All internal particles they are taking in a what motion? Everybody, circular motion. Okay, and maybe about a pivot point or without a pivot point also. So that is what we used to call as rotational motion. With pivot or without pivot, if a sudden jerk, sudden force is given, the sudden force only we used to call as what? Impulse. So whole body will start rotating about a fixed point. So that is what we used to call as rotational motion without impulse, sorry, without pivot point. And then what we are going to study this all the things, linear motion and angular motion. So that is what rotational motion, the terminologies and all from here will continue in the evening class. I hope you all understand, everybody. Okay, so with this I'll stop. So whatever the doubt you can ask me. Then evening, now get back to the work after 10 minutes. By 6:40 or 6:50 you can get back to the work and study till 8:30 another subject, whatever you are left that you continue. And then 8:30 to 9:30 have dinner and relax, and 9:30 we'll get back to the work. Okay, so this I'll stop. We'll meet in the 9:30 session. Thank you, everybody.